Okay, another one of these distance problems. Keeping in mind, guys, what's our formula? Distance equals rate times time. Yeah, you got it. Okay, now let's read this problem and decide, is it two cities coming towards each other, one city going away from each other, or is it starting at the same point, one going faster than the other? So let's decide. It says, a train leaves Little Rock, Arkansas, and travels north at 65 kilometers per hour. Another train leaves at the same time and travels south at 85 kilometers per hour. How long will it take before they are 600 kilometers apart? So let's identify some things before we draw our picture. First of all, what are they asking for? Yeah, I hear that. How long? What does that indicate? It indicates the time, right? That's what we want to know, the time. How long is it going to take? So we're going to find the t up here that's in our formula. Now, how far apart are they going to be? Yeah, I hear that. 600 kilometers. Now, how many cities do we have? One or two? Yeah, I hear that. One. One city, Little Rock, Arkansas. So when you think of that, one city, what does that tell you? It tells you it's going to start at the middle, right? It's going to go from the Little Rock and it's going to go two different directions. Okay? And how many trains do we have? Two. Yeah, you got it. So let's draw our picture. We're going to start from Little Rock, Arkansas. This is Little Rock. And we're going to go one train in this direction and one train in this direction. So this is train number 1 and train number 2. So we have two trains. Now, what's our total distance? Let's put that on our chart too. Yeah, I hear that. 600 miles. No, kilometers. Better get my right one. 600 kilometers. We're in America, so it ought to be miles. In Africa, it's kilometers. Okay, now, let's look at this. How fast is train number 1 going? Do I hear it? Yeah, I do hear it. I'm going to change color so we can see it better. It's going at 65 kilometers per hour. And what about the other one? Yep, you're right. 85 kilometers per hour. Now, what are they asking for, you guys? Yep, they're asking for the time. What's my time going to be? Yeah, we're going to use that t because it's the same thing that's in our equation, t. So, to get the distance of train number 1, it's rate times time. So rate times time. Train number 2 is also going to be rate times time. Okay? Now let's move to an equation. First of all, let's write it down here as distance of train 1 plus the distance of train number 2 is going to equal our total distance. Okay? Just like the other one. You see how the patterns follow on through on everything. So now let's move over and change this all into numbers and letters and into a regular mathematical sentence. Distance of train number 1. Yeah, you got it. 65t. Plus the distance of train number 2. I hear that. 85t. And what's my total distance? Well, let's look at our picture again. 600 kilometers, or 600. And just like in the other one, we're going to solve for the time. And remember, the time is how long it takes. So we've got 65 plus 85. T is 150 t. Okay, I think. Yeah, 10 carry my 1. Yeah, 150 t equals 600. Now, if you were a real class out there, you'd tell me if I was right or wrong. Okay, so now we're going to have that next step. It's multiplication, 150 times t. So the opposite of that is division by the exact same number. Both sides have to be treated exactly the same way. 150 divided by 150 is 1. So you're left with 1t, or just plain t, is equal to 600 divided by 150 is 4. And so we have 4 hours is how long it's going to take. So what was the question? How long will it take before they meet? And our answer is 4 hours. Notice again, I label it because it is a word problem. Okay, you guys are getting it. Good job.